All right, welcome everyone. Thank you for coming to the Seattle Rust User Group March Meetup. So we're here today at Microsoft campus, and we say this every month. We operate under two codes of conduct. One is the Microsoft Code of Conduct, where we're guests in their facilities. The other is the Rust Code of Conduct. And the sort of the high-level summary of both codes of conduct is a request to treat each other with dignity and respect. If you find that anyone is not doing so, please let them know. And if the behavior persists, then please let me know, and I will step in to help from there. So how many folks are new to the Rust meetup? By show of hands. Oh, we've got a good crowd tonight at the new Rust meetup. So welcome. We're a very friendly group. Yeah, come on in, take a seat anywhere. We like to get to know one another. We like to chat a lot about, all kinds of random things, as you might imagine. And so what I like to do is to kick off each meeting with an introduction. And the folks who've been here before have heard the same introduction from me so many times. Now I'm going to try something different and maybe go last or not at all. Would anyone like to introduce themselves? You don't have to be new, you can be. Just tell us a little bit about something about maybe what brought you here or how your career got started in software engineering.
Hi, everyone. My name's Andrew. I came to two of these in 2024 and then just had a run of bad Thursdays where it just never worked. So I'm glad to be back. Hello again. I work for a startup called Scythe Robotics. They're based in Colorado. They make lawnmower robots. They run Rust. So I love writing Rust and then seeing it cut grass. That's my story.
Very
Who's
cool.
next?
Hello. Hi, I'm Dylan, machine learning engineer at a startup doing computational biology work. Coming here from a scientific Python background. Was entranced by UV, which is a new tool. Am a good part of the way through the nicely written Rust documentation, and that's where I'm at right now.
Hi, I'm Josh. I've been writing Rust since early last year. I write Rust for spacecraft.
Nice.
Amazon.
Do you have any in space? Do you have any Rust in space yet?
I assume we. I personally don't.
Yeah, that's what.
But I assume we do.
Yeah. Oh, I assume you do too. But I just want to know: do you have any Rust in space? Soon, though. Soon, I'm sure.
Hello, everyone. My name is Ilya. Yeah, I started my career in late 90s coding in machine codes, so numbers. It was fun. Now I went from C, C++, Pascal, Forth, Lisp, all kind of things. I end up with Rust. I like it. And yeah, I'm also writing some code for space.
Nice.
Not there yet.
Not there yet. Okay.
I'm Jaden. I'm just a student, and I've used Rust since like 2 years ago, and I just like the language.
Very cool.
Hi, I'm Connor. I'm a student as well. I started with JavaScript, Java, and then I was introduced to Rust, and it was all uphill from there. But I love to live dangerously with bash scripts as well.
Great. Yeah. All right. Anyone else like to say hi? All right. Well, that's great. It's important that we get to know each other at break time and when we have our social get together after the meeting. There's often lots of things to talk about. It's great to connect with people who are sort of solving problems that you're interested in. So it's important, right, that our group is interactive and we get to know each other. So this is great. For the new folks, really briefly, my background is started with the Commodore 64 way back when there's dinosaurs running around the Earth. I found that the computer brought me to not machine language so much, although I did a little bit of that, but mostly assembly language, but writing it with a machine language monitor. So how about that? That means you're writing assembly language directly into memory. And so you do still write assembly language opcodes, but the machine language one-to-one translation is what's written into memory. And what's funny about that is when you're 13 years old and you're writing a routine and you forget a statement, like you need to put something between this line and that line, you have to copy a block of memory, right? Either the memory that follows, you have to copy it down by 1 or 2 bytes, or you have to take the block of memory that's above the statement you want to insert and move it backward by 1 or 2 bytes. And, well, you probably know where I'm going with this. No, you can't, because you can't jump somewhere else, because if you've forgotten a statement in your code, you have to insert the jump statement. No, I need to. Well, I could remove a statement, change it to a jump, do a bunch of stuff, come back. But when you're chasing the raster on a 16-bit machine, you don't even have time for that. So you have to move the statements. So what happens is when you copy to an overlapping region of memory, this is the thing that always confused me, but when you copy to an overlapping region of memory, it really matters whether you copy from the bottom or from the top. Because if you are copying, say, down 5 bytes, and you start at the bottom, you are going to probably do that correctly. And then if you stop from the, see, it's still confusing, and I'm not even 13 years old. Anyway, more times than I can count, this hand-assembled assembly language, what would happen is I would replace my entire program with the same instruction over and over and over again. And because this is being directly written to memory, there's no undo, there's no source code, there's no nothing. It's just live in memory. So, hours or even days of work would get destroyed by the fact that I couldn't rationalize how to move memory. So anybody who tells you like they're hardcore because they use Emacs or they use Vim or whatever, talk to them about machine language monitors, and then you'll have lots of stories to cry over. But this showed me, without me realizing it at the time, but I really did enjoy the low-level side of things. That continued through a career, and now when I discovered Rust, it's actually low-level but with high-level abstractions, so you can manage more complexity, and it's been very exciting for me as a journey. So I started with Rust in 2015. So we tend to meet on the 3rd Thursday of every month. There are some exceptions as holidays come in, particularly later in the year, but I just like to give people an update so that they can plan their schedules and know what's coming up. We are doing really well with volunteers. Thank you to Carl for posting the video that's being recorded right now to YouTube. He does the chapter markings and things like that, so that's wonderful. Ben, thank you very much for managing the talk schedule. So if you haven't already, or if you're interested in this group, there is a Discord server, which is that first link. And every month I say this because I'm still tamping out all the bad links, but this link should be good to go. You should be able, if it says expired, let me know and I'll fix it. But please join our Discord server, and then from there you'll see on the channels how to join this online and sort of the different conversations that are going on in between meetings. One of the things that you'll find there is Ben, and you can reach him at @bdillo. And he will schedule the talks. So for anyone who's interested in doing a talk, if you're working on a project, if you'd like to talk about something, if you would like to ask about something, do something interactive. Maybe you have a project that you'd like to get the collective wisdom of the group to work on collaboratively. I mean, everybody here is interested in writing code. So a live coding session where you're relying on the group to figure something out, I think would be more than welcome. So feel free to either come up to me if you have some ideas, or to reach out to Ben if you know you have a talk that you'd like to give. Anything you would like to add to that, Ben? Okay, thank you. Appreciate the help, you guys. All right, so then the last part that we would help, like for volunteers, what I'm trying to do is keep the commitment to an hour a month. So trying to keep it really low so that way people are not overwhelmed. And I don't know how long you spent with the backlog of videos, Carl, putting the chapters in, but how long did that? Yeah, okay. Yeah, so there was a bit of a backlog, but for a normal month, Carl thinks that should work. And how about for you, Ben, so far? Yeah. So like I said, if it's not if it's like more than an hour a month, anything like that, let me know, and then we'll just split up the responsibility and get another volunteer. If you'd like some backup, Carl or Ben, we can ask for another volunteer for that as well. So that way, there's more wiggle room. But for an hour a month, we're hoping to keep it really lightweight for everyone involved. Okay. So yeah, one more volunteer if someone's willing to update the meeting invite. Once Ben has finalized the schedule for a given month, we can put down the agenda for the meeting invite and hit send. That's a big one. It's no, this will be the meetup.com meeting invite. So yeah, if would anybody be interested in doing that? Ben would notify you when the meetings are all set up. There's a template. I have them copied out all the way out till June right now, and you're just going to hit send. But after June, you'll actually have to hit copy, and then you have to put in the the speakers, and then you'd be able to hit send. So that would definitely be 15 minutes of work max per month. Any volunteers? Anybody interested? Yeah. Okay. Yeah. Thanks. Appreciate it. Are you on our Discord yet? Yeah. What's your Rory? Okay. Well, reach out to me. Sorry. Reach out to. Wow, that's good. How long is this microphone? Anyway, reach out to me on Discord, and I'll get you set up with the credentials on Meetup. And yeah, appreciate it. Thank you, Rory. All right. So Northwest C++ Club. They're another group, and guess where they meet? Right here. Guess when they meet? Right now. So to save on staffing, the reactor schedules both meetings here in the building. And so Lloyd, their lead, approached me with the idea of doing a co-meeting sometime this summer. And so we're tentatively planning to have both groups here in July do a language panel. So I thought this was great. Lloyd's interested in talking about some of the other languages out there that are sort of supplanting some of the roles for some of the more traditional languages like C and C++. And what are their strengths? What are their weaknesses? Because a lot of people hear maybe a lot of hype or a lot of hearsay, but it would be nice to have some language panelists to be able to provide some actual facts about what things are good at and what some languages are good at and maybe what they might be less well suited for. So we came up with a list of languages that might be interesting. And we have quorum. So, but what we'd like to do is we'd like to cover a few more languages. So if you have any experience in these languages, I mean, Go would not be esoteric, but the other ones might be more esoteric. Some of you may not have heard of Circle, Hilo, or Mojo, but if you have any expertise, does anybody have any expertise, be willing to serve on a language panel to talk about any of these languages? I'm hoping somebody knows Mojo, because I would love to hear somebody talk about Mojo. No? Okay. Well, we're just looking around, seeing who we know. If you think you might know somebody, oh, yes. Great.
So if I want to know what this Hilo thing or they want to know what the Circle thing is, this is your chance to get to know what this new language is. We'll give you a template with 5 slides you have to fill out, and then there'll be a few questions asked afterwards. You don't have to be an expert. You don't have to fully learn the language. But if you just want to learn a little bit about it, this might be a great chance.
Thank you. That's well put. I'm half tempted to do it for Mojo.
Few slots then.
Well, how tempted to go all the way. No, it's just time commitments because there's some time commitments for this RustConf coming as well. So I gotta be careful with my commitments. But all right, so yeah, if you guys thinking about this, say hey, that would be kind of fun. That would be fantastic. Okay, so as I mentioned last month, I was gonna say last week, last month, RustConf is coming to Seattle. For those who are new, RustConf is I think it's the world's largest Rust conference. Maybe it's certainly the original one. There may be other ones that are bigger, but it's a premier event for the Rust community. The Rust Foundation has reached out to us and said that as the Rust community in Seattle, they would love to have our involvement. So they're looking for between 10 and 30 volunteers to participate, help with the conference. There are several roles involved. And Sam, I don't know if you're here, but I don't know if you're, I don't know what you look like because I've only seen you and chatted with you online. But Sam has volunteered to join me on what's called, what the Rust Foundation calls the program committee. And the program committee helps to determine what the talks are on the, for the conference. So we're going to be reviewing, the speaker, the proposals, and we rank them. And they have a way of, they blind them first so that you can't be like, oh, you're going to be fair, right? With respect that you're just evaluating based on the content. And then the speaker lineup is chosen. We will need some help, or they will need some help with registration, potentially with guides. They've been told that they're going to be opening up speaker slots specifically for the Seattle-based Rust community to speak. So if you guys have a talk where you'd like to do it at RustConf as one of the community-based talks, you're welcome to do that, and potentially other opportunities here to help out. The details that I know that are new from last month is that it has been confirmed that the program committee volunteers will get free conference. The conference will be comped or whatever they do. They give you a pass to the conference. And they also said that other volunteer roles would be. But what I'm not sure about is whether all other volunteer roles will be or not. So I will just say that at least some other volunteer roles will be. I would imagine that any significant commitment of time will be rewarded with free admission to the conference over the 4 days. But like I said, I'll have to wait until I get the final details from them before I can confirm that with you. I've had one question online. Is there a block? Somebody's coming up from Oregon to attend, and is there a block of hotels? Sorry, if there's a block of rooms at the hotel that are discounted for the Rust conference by the Rust Foundation? The answer to that is unfortunately no. There are no discounted blocks by the Rust Foundation. I don't know if I have any other questions that I haven't answered, but does anyone have any questions? Because it's helpful for me to have them, and when I'm talking to them next, I can make sure that I ask. Yes. Question was, is the location in the Seattle area known for this conference? And the answer is yes, it is. I think it's the Hyatt. Hey, you could just look it up. That's a good question. I do not know off with. Yeah, I'm sure it's probably close to the conference center. Oh, Sam is in chat. Hello, Sam. If you unmute, we'll be able to hear you.
Hello.
Hello, Sam.
I've been out a few times to the Seattle conference. I'm in Capitol Hill right now. I couldn't make it over today.
All right. Well, thanks, man. I appreciate your help. Okay, so where is this location? Seattle. 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 Yeah, it's going to be. Yeah,
I
don't.
feel like you're right when you say Hyatt, because I remember someone saying last month that that was correct. That was like
Yep.
somewhere around the downtown. Because I asked the question if it was going to be in Bellevue, and
That's right.
someone said Hyatt, but I don't remember what the confirmation for that was.
Yeah. No, I could check my email, but I'm. Thank you. Hyatt Regency Seattle. So, any other questions about the Rust conference? Yes. Discord channel. I have a thread. I think it's off the general channel about RustConf, and you can just join it there and tell me if you have any, restrictions. I want to be in registration, or I don't want to be in registration. Like, whatever. Let me know what your constraints are, and I'll work with you from there. Sorry, the question was, where do we register for volunteer? Yes, question. Same question. Okay. Any other questions for the RustConf coming up? Yes, sir.
By any chance, the dates of the CDB conf and whether those weeks overlap or not?
I don't remember, but
I believe.
let's find out.
Repeat the question for the bar.
Oh, thank you. The question is, do the RustConf dates overlap with CPPConf for 2025? And it's 2024. So I hear someone saying that it is 2 weeks after. Oh, there it is right here. September 13th to 19th rather than 2 to 5. So that's good news. So yeah, you got time to hightail it over to Colorado. Perfect. Okay, great. All right, so I will continue to update the group as we get more information from the foundation, what the other volunteers will be needed for, what sorts of perks that they will be providing to the volunteers, what's expected, what the time commitment would be, that kind of thing. I'll try to convey that to you guys as best I can, and you can let me know. Great. After we meet, we finally found a place. We've got a few more students now as well. So this is all great. Thank you for your help, getting us to this point. We will be meeting at the Red Robin at Redmond Town Center. We tried it for the first time last month. Worked out great. They had plenty of space. We were still yakking even when we closed the place down basically, and it was we had a good time. And the food was was pretty good. So you're welcome to join us. For those of you a little bit less familiar with the area, Redmond Town Center is the shopping mall that's just not too far away. It's not it's not really walking distance, a little further than that. But if you need a lift, I'm happy to take you down there and help you find a ride home as well if you need it. And I'm sure others are willing to do the same. All right. So as most of you know, you will be able to find the recordings of our meetings on YouTube. So go to youtube.com U007D, and you'll be able to see them and all of our past that we've been recording since October-ish. And again, thanks to Carl for taking that over and putting them up in a more timely manner. Tonight we will have two talks. SladeDB. It's a talk by I don't know. Hope I pronounced this correctly. Vignesh. Okay, I mean you say that's right, but I think you're being kind. How do you pronounce your name?
Vignesh.
Okay, Vignesh. See, that was not even close to what you said. Okay, so thank you, Vignesh. And then cool things you can do with pattern matching and destructuring with Lowell. So this is going to be good stuff. So I guess let's start with SladeDB. All right, so to get this to work, mute my microphone here.
Hey, can everyone hear me? Today we'll be talking about SladeDB. SladeDB is an embedded database built on object store. Let me start with my introduction. I'm pretty new to Rust. I started only a couple of months back. I don't use it at my day job. I now do data infrastructure at DoorDash. Before this, I was at Microsoft in Azure Stream Processing. SladeDB is an open source project that I contribute to for fun. It's a passion project. So I'm not a Rust expert. I'm very, very new. So that's a little bit about me. Now, with that, let's see what the plan for today is. We'll start with the motivation and share why SladeDB was started. I'll share what it is, and then we will get into the internals of how it is built. Let's start with the introduction. Object store is rising. Things like Azure Blob Storage, S3, and GCP, they offer very attractive properties. You can batch and then increase the latency and at a very attractive cost profile, offer a lot of good performance for customers. We see this in a lot of products. You see something like Warp Stream, which is a Kafka compatible streaming platform. It offers Kafka protocol and it stores all the data on S3. The compute is stateless. All the state is in S3. You see similar thing in table formats like Iceberg, Apache, Hudi, and Delta. They offer table storage over object storage. Now, this was the motivation, and SladeDB is a project that offers key value interface over these object stores. When you look at this, there are three common techniques that are used across all of these designs. One of them is immutable files. Files once written are never changed, and new data creates new files. The second is batched writes. I talked about this for a little bit. Put API calls are some of the API calls that are most expensive. You can increase the batching, and then with that, you reduce the cost. The third is conditional writes. This was not available in S3 until August last year or so. It is available now in S3. With that, it is available in all the major cloud providers. The conditional write, which is write a file if it doesn't exist, along with the technique of use predictable file names such as file number one, file number two, and so on. That is used to cause conflicts and so that two different clients don't overwrite each other's data. So these three common techniques are used in a lot of products. That's what is used in SladeDB as well. With that, let's get to what is SladeDB. It's a Rust library. It's an embedded key value store. If you use RocksDB, it offers a very similar interface. There is get and put, and it has range reads. It's implemented as a log structured merge tree. It is useful for cases where a little bit of latency, like 50 milliseconds to 100 milliseconds, is reasonable. Some practical use cases are stream processing, state store, durable execution, durable caches, and so on. There are two companies that are using it in production today. One is Responsive. Responsive is hosted Kafka streams. They use SladeDB for a custom state store, and TensorLake is an AI company. They ingest documents and create context for LLMs. They use it for storing data as well. Now, with that, I'm not sure how much you can see on the screen. This is an example of how you can use it. There is not a lot going on here. It uses the object store crate. You create the object store crate, and then you pass in a couple of properties. With that, you have a database. You see two sections here. The first section is doing a put, and it's doing a wait. what that will do is it will exit only after the data is durably returned to S3 or any other object storage. In the second loop, it's writing 1,000 keys, but you see await durable false. What that will do is the await will exit even before the data is returned to object store, and the flush call that is happening at the end, that's what will make it durable. And this is the crate. So with that, I'm going to go into the internals of what happens when you do a put. There are a couple of terminologies. As I shared earlier, this is built as a log structure merge tree. And the first is the SST file. It is a binary file. It has key value pairs and a little bit of metadata. Two important metadata that is there in the SST files are Bloom filter and what is the first key. There is a little bit more than that. And then there is a terminology called as write ahead log that's used. It uses the same format as SST. I'll share more in the upcoming slides. After that, there is the sorted run. It is a set of SST files, and each of the SST file has non-overlapping keys. Manifest file shares the state of the database at any point in time. So the state of the database is the set of SST files that are part of the database. With those terminologies, let me get to the writes. In the next slide, I have a sequence of what happens, but let's start with this picture first. There are two sections that you see here. One is the memory section. The second is the object store section. When you do a put, all the data is in the in-memory structure called as wall in this picture. And at some frequency that's defined by the user, that's returned to object store in the folder called WAL. Here we see 73.sst. That's the first write that happens to object storage. And there is another property called as L0 SST size bytes. When that limit is hit, it also creates a file in the compacted folder. Writes are durable the moment the data is returned to wall, and these files are numbered, so two different clients will not overwrite each other's data. This one shows what happens in each of the step. In the first step, what we see here is it's doing a wait. And when it does that in the object store, it would create the 001.sst. In the second statement, it is not waiting. In that case, nothing changes in the object store. And when you flush, you see that there is another SST that's getting created. Finally, in the fourth step, let's assume that a lot of keys were written and we hit the L0 SST size bytes. There is the XYZ SST that's created, and there is a new manifest. In the manifest, you see that L0 has the file xyz.sst. There is one more property here that is interesting. That's the last compacted. There you see the number 2. What that means is write ahead log 0, 01, 002. They are no longer part of the database. They are in the xyz.sst file. So that's what happens in write. As I'm describing this, I'm skipping over some of the details to fit it into the 30-minute or so of talk. It also creates empty wall on initialization and few other aspects that I'm skipping today. The next thing that is interesting here is compaction. Compaction is taking a set of files, creating another set of files that is more optimized. I'm not getting into the details. If someone is interested, I can get back to this later. Now, let's assume that a couple of writes have happened and a couple of compactions have also happened. This is an example of how the state would be in object store. What we see here is there are multiple write-ahead log SSTs. There is one called like 73.sst, and you see compacted has additional folder files, and there are a lot of manifests. All these files are immutable. Okay, now let's look at the manifest and look at some of the properties. The first one is straightforward. It is a manifest ID. Every manifest has an ID, and it increases from 1 to 3 and so on. Writer epoch is the epoch of the writer that created this manifest. It's also incremented every time a new writer is created. There are few other properties. Here I'm showing a simplified manifest. I talked about the val ID last compacted before. The other one, L0 last compacted. Every time compaction runs, that particular property is updated. Two other properties, L0, that is the set of SST files that's waiting to be compacted. And compacted is a sequence of sorted runs. And each sorted run is a sequence of SST files. That is what is there in the manifest. Every time an update to the database happens, a new manifest is created. There are a couple of different kinds of updates that happens. When a new writer is created, the epoch will be incremented and a new manifest will be written. When an L0 file is added, then the array that you see here that talks about a list of L0 SSTs, that particular array will be updated and a new manifest will be written. Compaction, when it creates a new sorted run, that would also update the manifest, and writer initialization will create the manifest as well with the incremented writer epoch. So essentially, every time a change to the database happens, a new manifest is created. Reads are very similar to the writes. It starts with the mem table and goes down the stack in the sorted runs. And again, L0 has overlapping keys, and the sorted runs have non-overlapping keys. Okay. So I talked about L0 creating an SST file and then updating a manifest. And I also talked about write-ahead logs that are no longer part of the database, but are there in S3. So these operations create files that are not referenced by anything anymore. Also, every update creates a new manifest. So there are a lot of these files lying around. Garbage collection process kicks in at some frequency, and then it deletes those files. Compaction is another kind of a maintenance operation. Compaction, it is a regular LSM compaction. And the interesting thing about the design of not having any state and keeping all the state in S3 is that these maintenance operation can now run in a different process, in a different machine. And this is how one of the users or responsive, I think, they do run it in a separate process. Now let's talk about checkpoints and snapshot reads or time travel reads. Because every change creates a separate manifest, you can use an old manifest and open a read-only database that will give you the state of the database as of some time back. That property is very interesting for something like a state store, where you could have two different consumers and each consumer is looking at the database at a different point in time. And in Delta, this is kind of marketed as time travel reads that comes for free with this kind of design. Now, I talked about garbage collection, and I also talked about reading from an old state. So garbage collection can delete the files that are not referenced by the current manifest. So to avoid that from happening, you can checkpoint. All that is going to do is there is a checkpoints array, and that will be updated with the ID of the manifest that you want to be checkpointed. The other interesting thing is the writable clone. Because all of these files are on S3, it's very, very easy to create and very cheap to create a writable clone. The only thing that had to change in the manifest is a reference to a parent database. So the metadata is copied over, but the actual SSD files are still referenced. With that, you can easily create a writable clone and continue. And these two databases can continue to exist independently. So with all of that, here are the features: zero disk, a single writer. You can have multiple readers. There is caching implemented as well. Things like manifest files, the metadata, Bloom filters, even the SSD files, all of that can be cached locally, improving the read performance. There is snapshot isolation and compaction that can run independently. There is checkpoint and writable clones. And here are three things that are coming up in the future. One is language bindings for other languages like Java. Transactions, the RFC is still being discussed. That will be coming up soon. Change data capture is coming up soon as well. That will let you continuously stream the state of the database to another system. And that's what I had. So this is the crate, and there are a couple of good first issues, including documentation updates and few low-hanging fruits if you're interested. Yeah, that's it. Questions?
Mic check.
Hello. Question. You mentioned garbage collection and sorting. So is it some separate process that's running, or it's writer? How it's happening? Like it's library, right? So for garbage collection, you need somehow invoke this garbage collection. You need somehow invoke this compaction. So how it's happening?
Yeah, there are two ways in which it can happen. There is a admin utility. You can run that admin utility and then it can do a one-time compaction, or the process that is the writer can act as the garbage collection as well. It has a thread that wakes up at some point in time and does it, or you can have a separate garbage collection that will continues to run and again only kick off garbage collection at some point. So you need something that's long running.
Okay. Second question is about single writer. So what exactly it mean practically? It's like only one thread can write?
Yeah, what it means is you can have multiple threads that can write, but there is only a single process. At the initialization, what happens is a new manifest gets created and an empty write-ahead log is created. So let's say you had a second writer that will attempt to write a write-ahead log, and it will hit a conflict and it will exit. The principle that we want to keep is that there is only one writer that is active.
Okay, thank you.
Hi. So I've only used S3 a little bit, but my understanding, and correct me if I'm wrong, is that in theory, I could take my little keys and values and just throw them directly in S3 and treat it as a key value store.
Yep.
I assume that would be really slow and expensive or both and other problems. So is that because S3 should be doing a lot of this stuff and they just haven't done it yet? Or how do I understand like why S3 isn't good at doing this kind of thing?
So S3 is designed as an object store for storing a little bit larger files. It is not even intending to do something like a key value store. There are other services in AWS that does it. And yes, you are right. If we could just keep it in S3, but then that will be expensive. You need to do some kind of a batching, and then you need a way to organize these files. And that's what SladeDB does.
I'm very inexperienced with any of this like cloud infrastructure stuff. So this is probably a super basic question. How do you think about like the natural limits of this approach? Like what does this, where does this hit the wall? Where does this stop performing? Where like what would limit this from being used on any kind of like key value problem?
Yeah, there is a benchmark that is on GitHub. This thing that runs every day. You can look at the numbers. There will be two kinds of limits. One is S3 will have limits on throughput and the number of operations that it supports on a particular bucket. So that's the first kind of limit. And the machine that it runs on, that will have some kind of a limit in terms of amount of operations per second that it can do. So that will be the second kind of limit. There would also be a back pressure. I was talking about these L0 files and all of these compactions that are happening. It is possible that the writes are happening so fast that the compactions are not happening, and with that, the read performance will be very bad. So there are some defaults that are set in terms of if it is falling behind a certain number of compactions, then stall the writes, right? So those three kinds of limits would be hit on specific numbers. I don't have it right now, but it is available through the performance runs.
Sorry, I have low voice today. So just before asking my question, I want to understand, you said that you will batch writes, right, to optimize performance. So what happens if while you're writing on the wall, things are batched, the process die? Do you have data loss? How do you have some sort of journaling? How do you figure out if things, as you were writing, were batched, what went through, what didn't go through, and if you can recover the data that you were writing?
Yep, that's a great question. Yes, there will be data loss, and I shared a couple of use cases where this is applicable. It is durable only after you call flush, right? Sometimes when you call flush, there is nothing to write. The flush milliseconds frequency kicked in, and then it wrote the data. To be sure, it's always important to call flush. But the use cases that I was talking about, let's say state store for stream processing, your data is already in something like Kafka, and you are reading that and then doing some transformation. And as you do that, you persist in the state store, and then you send it to your output, right? Now, you can control a lot of this in a process like Kafka streams. There, it's okay for you to not flush on every write.
Do you have a way to know what was in the queue to be flashed? Let's assume you have a Kafka stream. How do I know what um, what items in the stream went through the pipe? Do you have some sort of journaling in process? Or is there any plan to have some sort of journaling?
That journaling will be in the user application. So yeah, in the case of Kafka streams, that the Kafka streams program will have that kind of journaling. Thank you.
Thank you. Okay, so let's take a 10-minute break, and then we'll come back for our second talk.
Place to sign up for volunteering.
Actually, that's in, but it's in. And then. Let me Okay, so this talk is by Lowell, and this will be cool things you can do with pattern matching. Okay, so take it away.
All right. All right. Sorry for whoever had headphones on there. All right, so I'll start with an introduction. I'm Lowell Thorner. I'm a student at Western, finishing up there very shortly here. I don't work in software development, but I have been working with Rust for about 2 years, a little bit more than that at this point. And mostly right now, I've been working on a lot of things adjacent to databases and web applications. But I had noticed last time I gave a talk, there were some people asking questions about a couple of the ways that I had taken the like macro input and turned it into a couple of different variables. And I thought that that would be a good thing to give a short talk about because it's kind of a cool feature of Rust that isn't super obvious and isn't particularly common among other languages. So, if you're in something like TypeScript, you're going to end up having a bunch of types that are like maybe undefined, and then you end up having to kind of chain together operators and field accesses and stuff to figure out whether that thing is actually there. Whereas in Rust, there's a very robust system for pattern matching. So that's what I'm going to be demonstrating here. There's a example that I've basically built here. It's a little bit contrived, so bear with me. And we'll be going through a couple of different types of pattern matching and places that it can be used. At the end of the day, it's all essentially pattern matching. It just comes down to, what context it's used in. So anyway, so basically, what I've set up here is there's this struct called person. Contains a name, an age, a profession, place of birth, eye color, hair color, height in centimeters, and weight in kilograms. These are obviously just a random collection of data about people. Oh, it needs to be bigger? Okay. Yes. There we go. So a person, you might represent them in some system where you're collecting data about them. So you have your person struct and all of its contained data. And then the actual types involved in this, there's obviously the standard library types like string. If I can turn off the hints here, it's not very helpful. So there's obviously like string and U8 and U16. These are all built in the standard library, but there's other ones that aren't. And so I have these up here. So like you have your profession, which is just an enum. And I gave one of them some inner data to give you guys an example of how to extract that later on. And then I also have color, which is another enum, which doesn't have any tag data with it. So it's pretty simple. I just use the Roy G. Biv colors. So it's not particularly accurate to say that people are going to have hair colors of just red, orange, yellow, green, blue, indigo, violet. But again, bear with me. Then there's also the place struct, which is kind of again, very contrived. There's a string that tells you the city name, and then the U.S. state, which in this version of the U.S., there are only 4 states, California, Texas, New York, and Florida. And the coordinate, which is just 2 F64s in terms of latitude and longitude, or I think it's longitude and latitude rather. The main function you see here is going to have a couple of different people I've defined. I've done 4 different people. Persons A through D. They have various professions and various places of birth, et cetera, et cetera. At the moment, we don't really have to worry too much about that, but you can at least see how you would normally construct a person. So obviously in some instances, you might want to have, a variable representing the place that they were born, and then you use that as a value for the field when you create the struct. So if I wanted to, let's say, move this outside of here, so like say let Bob Smith place of birth equal place, and then, you know, in Jacksonville, and then I could put that in here. But there's not really any reason to do that in this case because we're declaring the whole thing together. And one of the cool things about Rust and about pattern matching is that you can actually basically pull this data out all in one step as well. And so that's what I'm going to be demonstrating here. I'm going to move this back to the way it was. And I have a couple of examples that I've basically just removed from the project temporarily, and I'm going to be expanding them and talking about each of them. So, because I don't trust myself to remember exactly what I wrote in my repository here. So, this is going to be an example of destructuring a type using basically just a let binding. So, if you have a type and you want to, is there like a what does anybody know what this setting is called where it pops up with all these things? I don't know. I'm just gonna leave it. I usually don't have my screen zoomed in this much, so my mouse keeps hovering over things that they wouldn't normally. This is a example function. You know, the function is just a Boolean return saying whether a coordinate is in the northern hemisphere, represented by a latitude that is more than 0, so above the equator. Now, of course, I went through this and realized after the fact that all of these are in the northern hemisphere because they are, in fact, coordinates that I picked randomly from Google Maps in these actual cities. And America is not in the southern hemisphere. So this will always return false for any of the people that we've given an example of here. But for the sake of argument, let's just say that it is actually a useful thing to do. What you're doing is you're taking in a coordinate, right? And in this case, I'm taking a reference to a coordinate, although you could always just do this and that would be fine, except you'd have to remove the dereference operator there. But when I want to get the latitude, because I don't care about the longitude, instead of saying, you know, we'll remove this for a second, instead of saying something like let latitude equal coordinate dot 1, right? Which I think is kind of not all that helpful in terms of trying to go back and read this later. You can instead do this, which is what I had before. If I can there we go. So basically what I'm doing here is I say, you know, here's the structure. It's a tuple struct, so I have 2 different fields essentially, and they're unnamed. But I'm going to give them names, and that let binding will now bind these 2 values to F64s, or more specifically, references to F64s here, instead of binding the whole variable, because we already have that in the form of this chord parameter. So when I want to do this, basically, I'm going to remove this real quick. Just going to type it out manually so you guys can kind of see what I'm talking about. So you would give the essentially the struct definition, and then you'd have, like, you know, field 1 and field 2. In this case, you can give them arbitrary names, so you could do X and Y. Not exactly accurate in terms of positioning as far as coordinates go, but let's just use that for the sake of argument. And then equal, and then the name of the variable that you're basically destructuring. And then I take the, in this case, the Y value, and I check if it's more than 0. Now, that obviously is, you know, giving me this error here that says unused variable X. So there's another thing you can do called the wildcard pattern, which is similar to how you do this in a match statement. You might be familiar with that, where you just give it an underscore, and then it stops complaining to you because you're basically just throwing away that data. So if we said latitude here again, removed latitude, There we go. So now it's basically just saying, give me just the latitude and not the first field here because it's not helpful. Yes. What do you mean by that? Yeah, so the question is, is the compiler going to generate any, you said any code for longitude? Yeah, so no, I mean, it's the value still exists because you're obviously passing in a reference to it and it's not optional. I mean, even if it was, it technically would still exist as a sum or a none, but that's beside the point. It does exist, you're just not actually binding it to a variable here. You could also do something like, if I can avoid getting the pop-up here, you could do something like this, I think, and it would still not give you any complaint. So if you wanted to do this to kind of make it a little bit more readable and say, I'm not actually going to use this, but I do want to denote that I'm throwing it away, essentially, you can do that as a more... Yeah, you can use that as a slightly more verbose version of this. Now, one thing that is kind of interesting about this, and I'm going to give an example here of kind of the exact same function, but a little bit different, is that you don't have to do this in the function body. You can actually do it in the function signature. And what that looks like is this. So instead of destructuring it with a let binding, you can actually just do this within the parameters of the function. One of the ways that I use this on a regular basis is in Axum, which is like an HTTP framework for Rust. There's handler functions for your endpoints, so you will have some method to get to them. So you have get or post or whatever, and then you have your parameters, which are going to be part of the extractor, part of the Axum system. So you can get your query parameters and some state for your app, etc. And in those sorts of situations, you would say something like, because they're tuple structs, you'd say like, get whatever customer data handler, right? And then you'd have query parameters, and then you'd have like query and then parameter type. And you can do this, and that's fine, but if you want to make it a little easier on yourself, instead of having to go in every single time, you say let inner query parameters equal query parameters dot zero, right? You can just say query parameters, and that just essentially destructures it within the type signature, or that function signature rather. And then that way you can just use query parameters directly. So that's a good example of how you'd use this in the real world. In this case, we're just doing the exact same thing we did before, but in the function signature. So we're giving this little bit here, which is saying, give me the latitude, right? We can, of course, do this to make it stop complaining. And we're basically giving the type, right? We give names for the bindings, and then we have the type here saying this is what the actual type is going to be. It's a little bit redundant, but that's just how you write these. It's a little less weird when you get to bigger, more complex types. But also when you get to more complex types, you can't necessarily guarantee that you'll be able to do this. You can't do any sort of conditional matching in this. It's only stuff that's guaranteed to be there. So we'll get into conditional matching now. This is also, I guess I will mention, this is the inverse of the other function. Yeah. So this will always, yeah, so I misspoke earlier. Is in northern hemisphere will always return true. Is in southern hemisphere will always return false, and at least in the examples that I've given. So, yes. So I don't believe so because it makes the type different. Yeah, so is it okay to remove the ampersand before the first instance of coordinate type on line 143? And the answer is no, unless you also remove it here. And that's fine. It doesn't. Okay, let's try it. So he said that you should be able to do that as long as you just update the body of the function. So if we dereference this instead, yeah, that works, I guess. So yeah, now I know that. All right, cool. Yeah, so apparently if you have a reference type, you can just use the normal type and then dereference it within the body. That's cool. All right, so let's get into if let. So you guys have, let me actually ask people, raise your hand if you've used match statements. Raise your hand if you haven't used match statements. Okay, so most people have, but basically a match statement is a very enhanced version of a switch statement if you're familiar with other languages. And in this case, we want to figure out a description of the type of doctor that somebody might be. So I have this enum here, many different types of doctors. Obviously, this is not exhaustive of the types of doctors that there are, or this file would be a whole lot bigger. And I've just given them very basic descriptions for people who don't necessarily know the type of, know the technical definitions for it, right? So I was talking about match. So if you're familiar with match, you might have had moments where you're like, I just have two different cases, and essentially I only need to handle one of them in a particular way. And that's usually going to come down to when you're handling options and results, where you have inner data in one case and either no data in the other case or data that you don't actually care about. Because who does error handling, right? But the typical way to do this, instead of writing a match statement, because you could totally write a match statement, you could say, match person.profession. And in this case, profession is an option of this profession enum. So you could just say some profession, and then have a case where you handle it, right? And then none, and then another case where you don't handle it, or you do handle a none case. Whereas with if let, instead, what you're doing is you're saying if let, and then whatever data you care about, so let's say some profession equals person.profession, then this is the handling part. This is the equivalent of this part here where you can write your handler code there. And then else, and then you'd have some other thing to do here. Now, I have a slightly more complicated destructuring that I have to do here, which is to say that I want to specifically find, A, is this person employed, right? Are they not retired or unemployed? And secondly, are they a doctor? And if they are a doctor, then I want to perform an operation on the type of doctor that they are, right? So I'm going to remove this, and we're going to use this if let statement here. And so the way that I do this is this part right here. I say take person.profession, right? And then attempt to turn it into this value right here, right? So if it's some and it's also profession doctor, then bind kind to a variable that I can now use, right? So now that I have the kind of doctor that they are, I can take that kind, I can match on that and give like a return string, right? So sleepy doctor, heart doctor, skin doctor, etc., right? And I've put the to owned at the end because this is returning a capital S string and not a string slice. It's just to make it a little bit more concise. And then I also have to wrap this in a sum because this is actually returning an option string. Because if they aren't a doctor or they're not employed, then this isn't going to work. So in those cases, you get to this else bit here, and I just return none in this case. But maybe you want to have more complex handling in those types of cases, right? Any questions about that? Yes. Yeah.
But what in that case is the macro in statement?
I think so. The question is, if you didn't need to actually bind this kind value to a actual variable because you don't need to do any operations on it, you just care if they're a doctor, should you instead use the matches macro? And I would say probably. You can, if you have implemented partial EQ, you can also just use an equal statement. So I could say like if person.profession equals some profession doctor, and then like underscore. I think that probably would work. No, it wouldn't. Oh, okay. So I have to use if let still here. Yeah. So we'll give it this example first. Profession, and then you have your handler code, and then else, right? You don't actually have to have an else here, but this is one way you could do that, and then the other way is you can say matches person.profession and some profession doctor and underscore. There we go. And I feel like I have an extra. No, I don't. There we go. And this would obviously evaluate to a true or false, right? So that's totally valid. I don't personally use matches very much because there's usually not that many times when you would just inspect something's variety or kind without and just like throw away the inner data. But sometimes that is something you'd want to do. Any other questions about that bit? Yes. Yeah. Yes. The matches is a standard macro. That was saying. It's a Boolean, so basically it returns if it does match, then it returns true, and otherwise it returns false. All right, so I'll get rid of this. Now let's look at a slightly different way to write this. I think one thing that generally programmers tend to try to do stylistically is try to avoid obsessive or like excessive nesting, right? We don't want to have 15 levels of indentation because it just gets really hard to reason about what's going on. So one of the ways you can do that is to use guard clauses rather than nested conditionals. Raise your hand if you do not know what a guard clause is. Okay, looks like we have some people. So basically, a guard clause is using a conditional that would check a condition that will be required for the code after it, but if it isn't true, it would usually just return from the function or exit some sort of part of the process before you even get to that code, rather than saying, if this is true, then do all of the stuff inside of this block. So it's kind of protecting it beforehand. So if you're like doing, let's say, reading from a array, and you want to check like the length of that array. Let's say you have an array of values, and then you have a length field on that array that tells you how long it is, and you want to avoid reading on an uninitialized memory. You would probably say, if the requested element is beyond the length, then return none, right? And then or return an error or something like that. And then you can go on to say, just index into memory and find the thing that they asked for, right? So what let else is it's a way of kind of turning an if let statement into a guard clause, sort of. So in this case, I've used essentially the same function, and we're going to write it slightly differently. I think personally, this is a little bit nicer to look at, and maybe a little easier to reason about. So instead of saying if let and then have everything inside of there, I'm saying let some profession doctor and then bind this kind variable, right? Equals person.profession. Otherwise, return none. So this immediately diverges and keeps any of this code from running if kind doesn't exist, right? So if they're not a doctor or they're not employed, this immediately is just going to return from the function. And so then down here, I do the same thing that I did before, except I don't have to have it nested in another if statement. So yeah, I mean, this is a slightly nicer way to write this, in my opinion. And it also is really, really good for like error handling, where you might have like 15 things in a row that need to be done in order to get to the 16th thing, right? Every single one of them can return an error, and you don't want to have to say, okay, well, I'm going to have 15 levels of if-lets that say, if-let okay, data 1 equals whatever the function is, then if-let data, okay, data 2, and so on and so forth until you get to data 15, and then you're like, okay, I can finally do my operation, right? And instead of that, you can just say, let okay, data 1 equals whatever function you're doing, else return none, and then, or return the error that you received, right? So you can also do that with match. Totally fine to do that. It's just a little bit nicer way of writing a match statement, I think, because it makes it a little bit clearer that this is immediately going to diverge if the thing that you want is not there. Any questions about that bit? Looks like people got that. All right. And the last thing I wanted to cover, we covered the wildcard pattern. So having the underscore where you want to throw away data. Again, you can also just put an underscore in front of the variable name. It does essentially the same thing. I don't know if it does the same thing in the compiler. I would have to ask somebody about that one. Whatever the case might be, it's essentially the same thing for the programmer. There's one other pattern that you're going to want to know if you're working with destructuring or building a struct, and that is the rest pattern. And it's kind of like a wildcard, but not quite. So the way that works is when I want to take a type or a value, and I want to turn it into some inner data that I want to access. In this case, I have a person. They're guaranteed to have a hair color and eye color. That's just part of the person struct, right? So I just want to return their hair color and eye color. I made a function to do that for whatever reason. Maybe I do this a lot in my code, right? So I don't want to write this every time. So I take the person that I am taking in this function, and then I create this sort of destructuring pattern type of thing, and I say hair color and eye color. And what this does is it binds hair color and eye color to variables of the same name, right? I could also, if I wanted to say, well, I have this field that's named hair color, but I want to bind it to a variable called, hair color 2 for whatever reason, right? You can do that by putting a colon here and then giving it a new name. You could also be really explicit and do this and say, I'm throwing it away. Generally, you're not going to do that. And so instead of saying, name underscore, and I just want eye color or whatever, right? And weight, kilogram, underscore, etc. Instead of doing that and just saying, I'm throwing away every piece of data that I don't care about here, you can just write this, ... and that says, throw away everything else in this struct, right? Now, this is kind of a multi-purpose operation, and in this case, we're using it to throw away data, but I also used it in a certain circumstance up here to create a structure, or like a type, not a type, sorry, a value of a type. So if you look at the person type, you'll see that I've implemented default for it, or derived it at least, right? So a default person basically is going to have no name, age of 0, no profession, place of birth with some random, coordinate 0, 0, right, on the, whatever, the prime meridian and the equator. I don't even know if there's land there. And then eye color and hair color that are, in this case, I've given the default color as green, so green eyes and green hair. They also have, let me go back here, a height of 0 centimeters and a weight of 0 kilograms. Obviously, this person probably doesn't exist, but if you're just initializing a person and then you're going to populate it later, you could create a default person. So if you want to do that, generally, you might want to give some data at least to start out, right? So you might give a name, you might give a height, because maybe those uninitialized values don't really, or those default values don't really make sense in context, i.e. height being 0, that doesn't really make any sense. Maybe you know the person's height, but you don't know what their profession is yet, so you're going to populate that later. So in this case, I know this person's name, I know their age, I know their profession, I know their place of birth. Apparently I don't know their eye color, hair color, height, or weight. So I use the rest pattern, which is that ... and then I say default, default. And this looks a little bit magic, and I will say this is something that bugged me to no end when I started using Rust, because I felt like this was just some weird magic syntax, but it really isn't. What it is it's saying, here's another type, or another value of the same type, and I'm essentially merging the rest of these values, like the rest of the fields from that type into this one. So if I were to say, give this guy, the rest of this guy's data is going to be populated by person C, you can do the exact same thing. Default, default is just saying, give me the default. It's like a default constructor, right? It's give me the default person, right? So in this case, he would end up inheriting, not quite the right terminology here. Don't think this has anything to do with inheritance, because it doesn't, but he would end up inheriting the eye color, hair color, height, and weight from person C. Yes. Yeah. Oh. Sorry, can you restate the question? Mm-hmm. Yeah.
Default tag at the top of that object, because the values that follow it are going to overwrite the default after it populates default, and then it fills it in with what.
Yeah. So
that's semantic. That's semantic I would expect. And
yeah.
And the other question I had was, so you've implemented default on person. Why don't you call person.default?
So the questions were, well, one of them is kind of like a comment. So it's like, in JavaScript, there's a similar system, but it kind of uses, you said the default declaration kind of comes at the beginning of when you start constructing the, yeah. Okay. Yeah, so JavaScript basically has the default declaration first, and then you write overrides as saying basically this is what the original thing was, and then here's the other values we're giving. That might have something to do with it being interpreted versus compiled. That's just a wild guess. It might be completely unrelated. It might be just a stylistic thing. Yes. Yeah. So the difference is, so what Brad is saying is basically, the difference is that in the case of JavaScript, you're writing the whole default thing, and then you're going in and rewriting the other fields, which is, a little bit less performant, especially if it's like a big struct. Obviously, the performance of JavaScript is going to be bound by a lot of other things beyond just the way that you're structuring your code. But then the other question was, why would you say default rather than just person.default? And the reason you would do that is because this is a constructor, right? It's not acting on an instance of a type. It's acting on the type itself, right? It's essentially saying this is the name. The type is like the namespace, right? And then you're saying I want to create a new one of these. So in this case, this is a trait. Default is a trait. And default is a function of that trait that is a constructor of whatever type is implementing that trait. The namespace operator in Rust is just : rather than dot in this particular instance, right? And it can infer that you are calling the default constructor for specifically the implementation of default on the type that you are currently constructing, because it's within a definition of that type. Does that make sense? Yes. Mm-hmm. Oh, yeah. Yeah, so basically it's a stylistic choice to an extent. So when I said the dot syntax doesn't work, I guess I'm being a little bit I was just interpreting that kind of pedantically. In terms of using the actual struct name itself, or like the type name itself, you could just say person default, because it implements default, and that's at this point just another implementation on this type, essentially. So that's absolutely valid. It's just less generic. Yep. Yeah. Absolutely. I think this might make it a little bit less obscured too. So that is also, I think that could be a better way to write it in a lot of cases. Anyway, any other? That's great. Yeah. Left angle bracket underscore right angle bracket default. There we go. Perfect. Thank you, type inference. All right, cool. Yeah. You could yeah, you could use some of that stuff in the function signature. Some of this isn't going to be available in that, because, like, I mean, in this case, this is like creating a value, but yes. What? Okay. So apparently Bevy has essentially just a plain wrapper function to default called just default. Yeah. Yeah. So the question is, can you write self instead of the type version of self rather than person? And the answer is yes, but no. In this case, no. You could do that if this was in an implementation of the person type. This is the main function, so that doesn't work. But if this was in, let's say I just had, like, create people. I don't know if main is a valid name for a function inside of a bare implementation, but let's say impl person, and then you basically do this, and there we go. And now self is a valid identifier. But outside of the scope of that implementation, it has no idea what self is, because self does not become an identifier within this this part of the code. Like creating a person, the self would not refer to the type that you're constructing there. I think the reason being essentially the benefit of occasionally being able to write something a little bit more concisely is going to be outweighed by the fact that if you ever write anything in a declaration of a variable, you're going to be switching around what self is referring to constantly. Because if I were to write that, let's say in here, all of a sudden it becomes place, right? That kind of is a little bit weird. So no, it would work if it was within a if it was in an implementation. So either of just a bare implementation or for a trade. Yes. Yeah. So yeah, so what he's saying is there's also patterns for basically taking, I guess, cutting like ranges from slices, or are you or like slicing into a variable, or are you talking about like you said popping the top and yeah.
That's square bracket head, comma, tail at dot dot equals that slice. That pops the head and the tail off the slice.
You said square bracket head like this, or is it lowercase or? Okay. In the square bracket. Okay. Um, oh. I have never seen that before, so that is really cool. Okay.
That's cool if you want to make a loop that munches like the first n number of elements out of a slice, and then you can reassign back to the original.
Yeah, I would love to rephrase that, but I don't understand it well enough to feel like I'd be confident enough to tell people. I don't want to misinform people. So if you would like to take the mic, I'd be happy to let you explain it.
All right. So the comment was that in a slice you can put a pattern where head represents the first element of the slice, and then the at symbol binds to everything else. And so therefore the second element in the pattern actually ends up taking on the entire rest of the slice itself. So that's useful for recursive patterns and for Haskell programmers out there. And
Doesn't need to be recursive. You can do it in a loop.
and you could obviously, recursion can be unrolled, right? But it's just an important thing to know about that you can do. Just
Okay, head, comma, dot, tail. Okay, yeah. So I don't know if this is this, it seems like the types are slightly different. Is this the same thing? Yeah. Okay.
So this example is getting the first and last element, whereas the previous example was getting the first element
and
then
everything else.
maintaining the rest of the slice in tail. So then you could do the same thing again, where you could pluck off the first thing from tail. This is actually you're just taking the first element and the last element from the slice.
Cool. All right. Any other? Yeah.
Can you return the previous version?
Sorry. Oh, yes. Square brackets. Second? Yeah. Dot, dot. I'm assuming, do we?
Don't need the extra square bracket inside.
Cool. Yeah. So yeah, you can take pretty much any like arbitrary values here. I don't know how you would do it if you wanted to do like, I want the fifth element. Is there a syntax for that? You can do, yeah, you can just do. Yeah. I don't like these type annotations getting in the way of what I'm trying to do here. All right, there we go. Sixth tail. Perfect. This is a little bit funky, but I guess it would work. If you had one that was, let's say, 500 bytes long, might be a little bit obtuse. You could make a macro for it. Yes.
So actually, if you add a whole bunch more commas, more underscores, essentially giving outer errors instead of the 10.
Yeah.
If you delete the word.
Yeah, the question we're getting at here is, because the folks at home can't hear the conversation going on, is what happens if the pattern, what happens if there's not enough data in the pattern for the slice to match? And the answer is these are called refutable or irrefutable patterns in Rust. And so if you are using the let statement, it must be irrefutable, which means you can't have an error. So because the hello world is evaluated at compile time, the compiler knows whether or not that pattern will be matched at compile time, and it will let you do it just until you run out of data, in which case the statement that was perfectly fine suddenly turns into a compile error. If you were dealing with runtime data where the compiler couldn't guarantee that correctness, then it would not let you compile it from the get-go, even if it was going to be valid with the data you were going to hand it. It can't prove it to be correct, so you're not allowed to do it.
But you can compensate by doing a match with empty. Like you can match on either an empty array or the head tail thing.
Cool. I'll take the two more questions, and then I think we need to wrap up.
Quote, hello world quote. Think of it as a slice, for slice config, and it's very, you can often use it as though it is. It's actually not. It's a reference to an array of a specific number. Of course, the compiler knows script, it knows. So it's actually not just a bracket, UA bracket. That's not a type. And if you use bracket, UA bracket, the compiler would be very sad. We have no idea how it's going to be, and you might not be able to match. So it's just one of the places where it's true nature. It's a reference to array matters.
Basically, it
But
said
yeah,
that the byte string declaration here, the B before the hi or hello world, is turning this into, from a string slice into an actual reference to an array of U8s. Which is required in order for us to do syntax like this, because otherwise it won't really be able to mess with these on an individual basis in this way. Is that accurate enough, or do you want to add some more context to it?
I probably talked too much already. Maybe just for the clearest demonstration of this,
yeah,
you could. So the way to turn it into a slice,
yeah,
there's different ways. But just put an ampersand in front of it,
yeah,
in front of the B, and then put the bracket dot to the right. Sort of like you would slice a vector or slice a string.
To the right of?
Right before the semicolon, to the right of the close quote.
Right before the semicolon.
Square bracket dot. So
yeah.
this is forcing it to be a slice.
And then do we have to put like this?
Yeah, the square brackets.
Oh, open close here. Yeah. Oh. Thank you, VS Code.
I'm causing trouble.
Oh, yeah. Yeah.
Yeah, so now you force it to be a slice, and we can see the compiler's just not going to have it, even though we know there's enough characters. So this was actually sort of happening under the covers in a way, or not. Anyway.
All right.
There's one more question I know.
And then who was it that had the last question? All right.
Is there like a deeper reason beyond just that it won't work? Like, why not just panic?
Yeah, so I mean, I think that it comes down to whether it's a part of the syntax of the language versus, let's say, part of the standard library. So when you want to index into a vector and the vector isn't long enough to index, like you're taking index 10 from a vector that's 5 elements long, it'll panic. But that's because it's part of the, I would say it's part of the standard library and the actual library around the language versus in the case of irrefutable patterns, the reason why you wouldn't want to have a runtime panic because of a irrefutable pattern that is inaccurate based on the type is that it essentially defeats the purpose of irrefutable patterns at that point because this is supposed to be guaranteed at compile time. That's my reading of it. You might want to talk to a compiler developer if you want to get more information about it. Yeah?
All right. Oops. Yeah. All right. Thank you guys very much. This is a great conversation. Thank you, Lowell, as well for your presentation. Let's go ahead and Vignesh as well for your presentation as well. Thank you. Yeah, another round of applause for our speakers tonight. Okay, so we have to make a quick exit because the folks who run the place have to go home and get some dinner. We can meet out front, say goodbye, but for anybody coming to the after party, Redmond Town Center, Red Robin.